Alright, hey everyone, we're doing FRQ4 for Physics C today. And so part A, free body diagram for the forces on these two blocks. Inner block first, M1. So this being acted upon with a force, T1. There's also a force T2 pulling it outwards. T1 is greater than T2, so this arrow should be bigger. I'm going to draw a little dot right here and say that's Fn, because the dot represents something, force coming at you. And then X for F of G, because that's the force going away from you. Now for part B, which is M2, it's only being pulled with the force T2 now, and the same thing as before, a dot, force coming at you, which is Fn, and then X, force going away from you, which is just Fg. So that's it. Part C, period for the outer block, so I will accept the equation V equals 2 pi r over t, circumference over time. I can isolate for t, so it's just 2 pi r over v. Now plugging in the numbers that they gave before, which is just 2 pi, the radius was 0.75, and the velocity is 4. So I get the time, plugging that into the calculator, you get 1.18 seconds. Part D asks for the tangential speed, so now I can just set it up again. V equals circumference, 2 pi r over time, t. So now I would use the inner circumference. This is the inner block now. So the radius for the inner block is 0.4. And then the time, since the blocks are connected to each other, they should have the same period. So it's just 1.18. Putting that into a calculator, V should be 2.13 meters per second. Alright, going on part E, I'm going to zoom in a little bit, save some space. Part E asks for the centripetal acceleration. So the first thing I want to do is set up V, which is just 2 pi r1 over t. And I know that centripetal acceleration is equal to v squared over r. I can just plug it in here. So it's just 2 pi r1 over t squared over r1. So I'll just get the AC or AR. I would distribute the square, so I just get 4 pi squared r1 squared over t squared over r1. This r1 cancels out with the square, which is that AR is equal to 4 pi squared r1 over t squared. That's it. Alright, moving on for part E, going to part F now. Just comparing AC M1 for AC M2. And so I know the AC formula for this in this case is just 4 pi squared R1 over T squared over 4 pi squared R2 over T squared. Just taking that straight off of here and just changing R1 with R2. And so this cancels, pi cancels, T cancels, leaving just R1 over R2. R1 is 0.4, R2 is 0.75. Plug that into your calculator, and you should get 0.533, which is the ratio between those two. We'll go on to part G now, which is just FC1 or f of c for m1 over f of c for m2, and then f of c is just mv squared over r1 in this case, and then mv squared over r2. And so the mass of the top, or the inner block m1, is just 0.05. The velocity for that is right here, 2.13. Saw for that earlier. 2.13, square that over R1 is 0.4. Divide all that by the mass of the outer block is 0.03. The velocity for it is given in the questions, 4. Square that, radius is 0.75. Plug the top into the calculator, you should get 0.567. And then plug the bottom of the calculator, you should get 0.64. And then 0.567 divided by 0.64 is 0.886. which should be the ratio between the FC1 and then FC for M2. Alright, now I'm going to do both H and I at the same time because they both kind of like go together. So H slash I. Or actually, no, I'll write the answer separately. So H. So first, I'm going to set up the net force for the first mass, M1. So that's just going to be T1 minus T2 equals F of C. So this is just T1 is equal to F of C plus T2. And so now I'm going to set up the forces for M2. So this is just T2 equals F of C. So T2 is equal to M squared over R2. Putting all these numbers in, for the second one, it should be 0.03 times 4 squared over 0.75. Putting that all in should get you 0.64, which is for T2. And so I would take this, I'll put it back in here. So I'll get T1 equals FC splits out into MV squared over R1 plus 0.64. So I would get T1 equals 0.05. The velocity is 2.13 squared over R1, which is 0.4, plus 0.64. If you do this out and you add it together, you should get T1 is equal to 1.2 newtons. And then for I, well, T2 is 0.64 newtons, as I found down here. Now for part J, I'm going to do it down here. So J asks for the net force on the inner block. So net force for M1 is just equal to FC. FC is the net force. So net force for the inner block is just equal to MV squared over R1. And so net force for M1 is equal to 0.05 times 2.13 squared over 0.4. Putting that into your calculator, net force for the inner block is just 0.567 newtons. Alright, now for the last part, it asks if both masses increase, what happens to both what happens to both T1 and T2. So first off, I will set up the net force for the second one first because that one's probably easier. So it's just T2 equals FC. So it's just going to be T2 equals MV squared over R2. This is M2. But let's see. If it increases, now you're multiplying by a greater number, which means that T2 should also increase. Now I do M1 over here. So this is just T1 minus T2 equals F of C. So this is T1 equals F of C plus T2. So T1 equals M1V squared over R2, R1. But then if this increases, but then we found over here that T2 also increases, that means that T1 also increases. So both increase. That's it for this FRQ. Thank you for watching, and tune in for the next FRQ, I guess.